This was the only question that gave any trouble in the paper one. It was a wordy question, and I've extracted the important bits. The rate of growth of insects is proportional to the current population. At the start, the population is 1,000. 1 week later, it is 1,150. Set up and solve a differential equation, determine the time taken to reach 10,000 insects, is the essence of it. What you should realize is that this bit here, what is it for? Why have they told us that? And that is entirely for us to work out what some constants are. There must be two constants because they've given us two bits of information. We're definitely going to put this one in first, because at the start is t equals 0. It's always the simplest thing, and I think you'll always be given that. Okay, we can forget about these at the moment because we have to do this first job first. Now we have a bit of GCS here. The rate of growth, that is dp by dt, is proportional to p. So we have this here. You should then know immediately what to do. We replace the proportion symbol with equals k. Simple as that. This is a differential equation, and you should immediately know what to do. There's only one thing on the syllabus, which is separate and integrate. So it's a very easy separation. Here it is. I simply divide by p and multiply by dt, kind of swap positions, except I don't write dp over p. I really want it to look like this, with the dp and the dt at the very right-hand side of their side of the equation. And remember that when you separate, you must also integrate. So there it is, separate and integrate. It looks lovely. It looks like two integrations that you can easily do. Clearly, this one is log p. And this one, a lot of students get confused by this. I would first of all move this k out. It's a constant. So let's not let it interfere. We know it's a constant because this says dt. That says integrate whatever's in here with respect to t. So that's a constant. But what is in there? It seems like there's nothing in there. Well, there is a 1. So integrate the number 1 with respect to time, and you get log p equals kt. Plus the constant, you only need one constant. We then do the classic couple of tricks. One is to do like the equivalent of an inverse logarithm. So this is base e. So when it goes to the side, it turns into its inverse function, which is e to the power. So I've got that here. Now you'll see this a lot. E to the power something plus something. So I'm going to break that up as e to the kt times e to the c. And I'm going to give e to the c a new name, capital A. So it's a trick that happens all the time. Really nice. We have the equation now. This is a general equation because it's got, in fact, two constants, a and k. And so we can make it a particular solution for the question that we have been given by finding a and k. So always start with the easiest one, which is t equals 0. Put that in. If you put t equals 0 into here, that e to the power just disappears, and we get p is equal to 1,000. We then put t equals 1 in, p equals 1150. Therefore, this equation here is looks like this. I've written out t equals 1. Obviously, I could just write k there. Solve n, and we get k equals that. And so we have our solution, which we should write that down. That's called the particular solution to a exponential model, which comes from this original setup where the rate of change is proportional to the size of the population. So if you've got a large population, the rate of change is high, and that should fit with your idea of what an exponential is. So we have that, and then the question says determine the time taken. So clearly we just put p equals 10,000. So 10,000 equals that. Let's do solve n. Dead easy.